Hey everyone, welcome back to Simple Chain Together, the series where we recreate a simplified version of the game Chain Together in Unity. I'm Lou, and today we're doing something interesting. If you've been following along, you've probably noticed that in the last episode, when the player jumps onto a moving obstacle, the obstacle moves, but the player just stays behind. This is not how we want our game to behave. Alright, to solve this problem once and for all, we're going to create a system that works for every type of moving platform. Instead of writing separate logic for different platforms, we'll create a shared interface that all moving platforms can use. This approach is much cleaner and more professional because it avoids duplicating codes and ensures everything works seamlessly. Okay, so inside the script folder, right-click, create C# script and rename it to iMovable platform. Double-click to open it. Okay, so let's clean up a bit. We do not need any of these, so get rid of that. Just keep using Unity engine and that's it. So here we need public interface iMovable platform. What is an interface? An interface defines a contract that classes must follow. It specifies which properties or methods a class must implement, but doesn't provide any functionality itself. Why we use iMovable platform here? It ensures that all moving platforms have a motion property. This allows the player controller to interact with all moving platforms in the same way, making the system flexible and reusable. So here vector3 motion is a property to track the platform's motion. Now let's save this and go back to moving obstacle. So here at the top we have mono behavior. So you know that mono behavior is the base class for all scripts in Unity that are attached to game objects. Here we add iMovable platform. What it does is that this means that the moving obstacle class implements the iMovable platform interface. By implementing an interface, the moving obstacle class agrees to provide definitions for all the properties and methods required by the interface. Okay. Private vector3 last position keeps track of the obstacle's position in the previous frame for motion calculation. And then here you have a public property called motion, which implements the iMovable platform interface and tracks how much the obstacle has moved this frame. We go to the start. Here in the start method, last position equals to start position. Last position is set to the obstacle's initial position to correctly calculate the first motion delta. Now inside the update method, we calculate the motion delta motion by subtracting last position from the current position. And then we update last position for the next frame. Okay, that's all what we needed to do with moving obstacles. Now let's go to player controller script. Now let's update the player controller script to work with any object that implements the iMovable platform interface. This way, the player can interact with both moving obstacles and other platforms. Okay, so here in this script, we add iMovable platform reference and we call it current platform. This is a private variable that stores a reference to the moving platform the player is currently standing on. Okay, Now, I think we need to create a method called handle movement. This method now checks if the player is on a platform and is also related to the player movement. So this modification ensures the player's movement is relative to both their own input and the platform's motion. We can use two variables, move horizontal and move vertical, from the update. We can completely use that. Don't worry, we will delete update later and then we do the modifications. So for now, let's just focus on handle movement method. We also can use the vector3 move direction completely from the update, so go ahead and copy that and paste it here in the handle movement. We still need the variable speed with a minor modification. And also vector3 movement with a little bit of modification. We just add time.delta time. We multiply it by speed and time.delta time. Now here, if current platform is not null, meaning the player is standing on a moving platform, the platform's motion is added to the player's movement. Current platform.motion gives the platform's movement delta, how much it moved in the current frame. And then rb.movePosition, rb.position plus movement. Okay, we are pretty much done with the handle movement method. Let's go to update and delete every line related to walking. So let's just call handle movement here, and that's all done. And these other lines are for jumping, so let's add something here as well. Current platform equals null to detach from the platform when jumping. Okay, that's all we need to do in the update. After that, let's scroll down, go to on collision stay. Here, when the player collides with an object, the script checks if the object has a component that implements iMovable platform. If the object is a moving platform, it assigns it to current platform. Why is this important? This logic detects when the player steps onto a moving platform. By setting current platform, the script knows which platform the player is standing on, allowing it to correctly apply the platform's motion. After that, let's go to on collision exit. Here, when the player stops colliding with an object, the script checks if the object is current platform. If it is, current platform is set to null. This is important because this logic detects when the player steps off a moving platform. By setting current platform to null, the script ensures the player no longer moves with the platform once they leave it. Okay, let's save this, go back to Unity. Let's check how our script is working. Okay, So let's jump. Perfect. As you can see, I press A, W, S, D, it is working fine. The player now moves smoothly with all moving obstacles, and we've built a robust system that works for any type of moving platform. And I think that's it for today's episode. If you enjoyed this tutorial, don't forget to like, subscribe, and share your thoughts in the comments. Thank you so much for watching, and as always, happy coding. See you in the next one. Bye!